Hello, we are going to talk about algebraic expressions. Notice there is no equal sign in the word expression. You can only simplify. Here's an algebraic expression. I've written it in different colors so that you can understand the different parts of an algebraic expression. You have coefficients, which are numbers attached to variables. You have variables, which are letters that represent a number. You have your operation symbols such as plus, minus, multiply, divide. And then you have constants, which are numbers that stand by themselves. The importance of understanding these things is because next we're going to be talking about terms. Here's an algebraic expression. We have 3x plus 4 plus x minus 1. I'm going to underline my like terms. My 3x and my x are alike because they both have x's. Whenever you have an x or any variable by itself, you just have one x. So if it helps you, you can write a 1 in front of the x. So I'm also going to underline my other like terms. I know I have a constant 4 and I have a constant 1. Now I'm going to rewrite the problem so that my like terms are next to each other. After I've written out my like terms next to each other, I now can combine like terms. So, when I combine my like terms, I have 3 x's and 1 x. I have 4 total x's. I have 4 minus 1, which is 3. So in simplest form, this expression would be 4x plus 3. Now, we also have to talk about terms. Like terms mean they're the same and you can combine them. But terms means you're talking about everything in the expression. If you had to list out the terms in this expression, you would list out every single item that is separated by an operation symbol. So your first term would be 3x, 4 would be a term, x would be a term, and 1 would be a term on its own. Every single thing in the algebraic expression is a term, but you can only combine like terms. We discussed the distributive property. The distributive property means you have to pass out or you have to multiply anything that is touching the parentheses by every single term inside of the parentheses. So I encourage you to draw an arrow. And wherever your arrow starts, that's the first number you're going to multiply. And wherever your arrow stops, that's the second thing you're multiplying. So 2 times x is 2x. Then you have to bring down your addition sign. Follow your second arrow, 2 times 3. 2 times 3, which is 6. Once you distribute the 2, your algebraic expression is 2x plus 6. That is in simplest form. You cannot combine them because you do not have like terms. You have a coefficient and a variable and a constant. Therefore, they are not alike. You can also take an algebraic expression and go backwards and factor out so that you can make the expression look like the distributive property. So when you look at 3x and you look at 6, you know 3 and 6 are both divisible by 3. Well, whatever is the largest number that you can divide both of those by, you are going to pull that out and put that in front of the parentheses. Then if you take 3 divided by 3, you get 1, or 1x. And if you take 6 divided by 3, you get 2. 3 parentheses 1x plus 2, which is the same as 3. So if you were to write this out, you really have 3 parentheses x plus 2. You can write 1x or you can just write x. They mean the same thing. We learned the commutative property. The commutative property states that x times y is the same thing or equal to y times x. Think about it. 5 times 1 is 5, and 1 times 5 is 5. They both equal 5. The commutative property says that you are just reordering the numbers. We have the associative property. A plus B plus C, parentheses are around B and C, or A plus B plus C, parentheses are around A and B. You are regrouping. You are just moving the parentheses. But either way you do it, if you input numbers 5 plus 1 plus 2, you get 8. 5 plus 1 plus 2, you get 8. It doesn't matter which group goes first, you still get the same answer. The identity property, you guys have been using this forever. A times 1 is A. Anything times 1 is itself. And A plus 0 equals A. Anything plus 0 is itself. Substitution. A substitute is when you place something in for something else. So they tell us y equals 2. Okay? Our algebraic expression is 3y plus y plus 4. We have to substitute the 2 in for every letter y. So we have 3 times 2, because this means multiplication, a coefficient and a variable, plus, bring your plus sign, 2 plus 4. Then you have to follow order of operations. Multiplication comes before addition. 3 times 2 is 6. Bring down your plus 2, bring down your plus 4. 6 plus 2 plus 4 is 12. Here's 2 more substitution problems. X equals 4, y equals 1. Well, the first algebraic expression is 8 minus y. Well, you had to substitute. You had to put the 1 in for the y. 8 minus 1 is 7. Over here, 16 over x plus 2. Well, a fraction is a division problem. So you have to substitute the x in. 16 divided by 4. Division comes before addition. So you have to divide. 16 divided by 4 is 4. Bring down your plus 2. 4 plus 2 is 6. You have to substitute in and then follow order of operations. When you're given an expression, you have to think about all the ways that you can write this. 5n plus 1 plus 5n plus 1 would also mean 10n plus 2, because you can combine your like terms, and 5n plus 5n is 10n. And you can combine your constants, which are also like terms, 1 plus 1 is 2. Therefore, this expression would mean the exact same thing as this top expression. You also could factor out or make it look like a distributive problem. And you know 10 and 2 are both divisible by 2. So your 2 goes on the outside. And 10 divided by 2 would be 5n. And 2 divided by 2 would be 1. Therefore, if you multiplied it back, you would come up with 10n plus 2. You have to remember how to combine like terms and how to distribute to determine what expressions mean the exact same thing or are equivalent expressions.